gas is also in short supply, it is a very costly kind of affair. By and large we are relying on electric supply for our hot water needs. So, then as was also mentioned that you have to have a trade off between the vented or whether you want to go in for unvented system. In the vented system, here you will see that this is fed from a high level cistern which provides the necessary pressure at the outlet, and vented hot water storage system provides constant low pressure and reserve water supply. Whereas in unvented system, water is usually fed directly from the supply pipe under mains pressure. It does not have a vent pipe and relies on mechanical devices like thermostat for the safe control of heat energy and hot water expansion. Now, what this means is that your instantaneous type of water heater, it is an unvented one. So, if lot of pressure builds up, even your storage water heater is a unvented one. If lot of pressure builds up and the thermostat does not cut off due to some mechanical defect or due to some maintenance issue, then there is a likelihood that the tank may burst even. So, safety is first for the inhabitants, and then as architects you need to be conscious of not to place such a equipment, preferably not inside the toilet as I was mentioning. So, let us see hot water requirement varies, this slide says. For example, in the case of the left one is a hospital. So, in a hospital there may be a continuous demand for hot water all day, and in this case a small storage capacity with a rapid recovery period which means a large boiler power is probably more appropriate. Whereas, in case of a pavilion or a sports stadium where there may be single sudden demand following at the end of a game, a large storage capacity and a long recovery period, small boiler power may be adequate. So, these are all the tasks of civil engineers, or to be precise the plumbing engineers. They are to be aware that this is the requirement. As an architect, you are just to tell them that this is the peak requirement, so many people will be there and so much water will be required. Now, let us jump on to after understanding the types of hot water systems. Now, let us jump on to the losses, which is a very important parameter in case of hot water supply. There are three different types of losses: primary losses, storage losses and distribution losses. So, we will first understand primary losses. The boiler should be positioned as close to the hot water storage cylinder as possible so that the heat losses from the primary flow and return pipes are reduced to minimum. So, here I think you should understand, dear students, that the boiler which is being mentioned to is a piece of equipment in which water is being heated, and then it is being the water is being brought to a hot water storage cylinder. So, what we are trying to say here is to minimize the primary losses, they should be close to each other. The next point says the best practice standard is that the primary pipework is insulated throughout its length. You need to have insulation, proper insulation on the pipework. Fittings and valves should be insulated also to provide the, for example, there will be T joints, elbow joints, some unions, some pressure reducing valves, all these things will be also insulated to avoid primary losses. So, fittings and walls should be insulated to provide the same insulation thickness as on the main pipe section, and then pre-insulated or district piping minimizes the heat loss when running primary pipe work underground from a shed or a garage to the dwelling. So, it is also a possibility that normally this happens in the western countries, in Europe and in America, that you have your boiler fitted in a basement or at a remote location outside the house, and then what is being said in the last point is that the pipe work which is connecting the boilers to the hot water storage cylinders, and if it is running through the ground underneath, it needs to have adequate insulation. So, pre-insulated pipes are available. Now, storage losses will also happen in the hot water cylinder itself. So, newly installed cylinders, the best insulating medium is that applied at the factory as part of the manufacturing process, mold injected rigid polyurethane foam PU, typically of about 3 inches thickness. So, in case you happen to open up your storage type domestic water geyser or water heater, if it goes bad या ख़राब हो जाता है जब उसको when you call the person, please try to notice, dear students, that it will have many layers of insulation. You will see only the metallic portion from the outside, and then there will be a layer of PU, and inside there will be a tank which may be of, normally it should be of copper. So the 20-liter tank which you are talking of, that is the inside capacity, and the you will see a huge structure outside. So as architects we have to be very much aware that if we are talking of a 20-liter hot water storage system, then what is its actual size, how many feet by how many feet, whether it's circular, whether it is rectangular, what shape you want. But at this stage I am trying to tell you that the hot water cylinder has to be very well insulated. For existing cylinders, an insulating jacket may be used and fitted so that there are no parts of the cylinder wall is exposed, and this is what is meant by storage losses. Distribution losses, hot water pipe, hot water supply pipe work should not be oversized, because if it is if the designing of the pipe work is of larger diameter, then it is going to lose that heat. It must be adequate for the pressure and flow requirements. So the best practice standard is that the hot water supply pipe work is insulated throughout its length, which is normally not done in Indian practice. What you will find is that when you ask your plumber in a new building to put up the hot water supply pipes also, there will be no insulation, will just be putting the normal GI pipes, they will not be insulated. So please make it sure from now onwards, now that you know that the wherever you are to leave a node for the hot water supply from the geyser to the end point, that piping should essentially be insulated. Insulated here means you just need to have a layer of PU about 1 or 2 inch. It is a difficult task because the plumbers, they do not want to do it, it is extra work for them. But as architects, I think you should be aware that the amount of electricity saved will be tremendous, because most of the heat will be lost as a distribution loss. You get my point? So these losses, primary losses can be avoided. Similarly, storage losses can be avoided if your cylinder is replaced. The insulation, supposing we'll just read down in the presentation about operations and maintenance also. So you have to check, because every liter of water you are heating, it's costing you money, it's energy, and the best practice is that you should have insulation everywhere. So ideally the hot water storage cylinder should be sited to minimize dead leg distances, especially to the point of most frequent use. So I think now we are well aware that the water heating system losses are primary losses, storage losses and distribution losses, which distribution losses as architects we are to be aware of and design the system and tell the plumber or whosoever is the executing authority to be careful and get it done. Okay, let us move on to operation and maintenance. So there is a generic sketch showing the central type of hot water supply system. Now what is important is that we need to operate hot water storage devices at 60 degrees, and now this visual is showing a hot water supply plant in a typical huge building like a hospital, you can say. So this is the kind of equipment, and as architects I believe it is important for us to know that what is the space required, what is the size of this machinery, how does it work. That is little bit difficult for us, but at least we have to leave some space, we have to design our building, whether this is to be in the basement, then what is the height of the equipment of the boiler and what is the size of the pipes. So dear friends, it is very important that we learn these things at the current stage when we are students, because later on when you go in the field you are going to be a flop if you are not aware that you have designed a hot water supply, you want hot water supply in your hotel, but you haven't left any space to put the boiler or the air conditioning equipment for that matter. So as a student you should always be very much interested, I must tell you, to learn about the services parts of the buildings, right. So services are very important, elevators, escalators, all kinds of advanced services, air conditioning and similarly hot water supply. So we should operate the device at 60 degrees and maintain the tap water at 50 degrees. So, drain and clean the hot water devices regularly to avoid accumulation of oxide, rust, scale, sludge, as I was telling you. And then hot water outlets which are infrequently used and are connected to stagnant water supply pipework shall be flushed at full flow for a minimum period of 1 minute at least once in a month. So, please understand the importance of operation and maintenance. Now, we are running short of time, I will quickly go through the rest of the slides. This is a hot water supply in residences. So, we have already discussed, you can have a look at this slide. There are two types, pressurized hot water and cold water plumbing system, and you could have a non pressurized hot and cold water plumbing system. Primarily the things are already described, the systems I have told you, but it is important to know the functional diagrams also. So, there are two methods used in domestic installation to overcome poor water flow at showers, because the normal problem is that you get the hot water in the tap, but as far as the shower goes, there the height of the hot water cylinder is kept as such that it is unable to provide the hot water. So, therefore, you need to go in for a pressurized system, as I have mentioned here. So, there are two systems, pressurized hot and cold water supply system. Here you will face no such problem, or you will have to install a pump additionally. One way is you go in for pressurized system, second way is you go in for a shower pump, right. This is the type of hot water required per person per day. This table for sink, for kitchen sink you need 18 liters, and temperature you will see ranges from 40 to 60 degrees, and the flow rates are mentioned, and accordingly the piping has to be designed. So, in hospitals you need water for tubs, showers, washing, kitchen, and then these are the systems used in hospitals. There is a heat pump technology which is currently very much in demand. In hotels you need hot water for rooms, kitchens, laundry, restaurant, pools. Then you have to see the selection based on what kind of water requirement is there, what is the temperature requirement, what is the funding available. Now, and very quickly we will also touch upon solar water heating. So, there are two types, one is the flat plate collector and the second is the evacuated tube collector type. There are some pros and cons of both the types of systems. The flat plate collector, this one on the left side, is cheaper in cost, but then the then it is not able to deliver the water at the desired temperature. It is heavier, and similarly the other one, the evacuated tube collector, this is made of glass. These tubes are made of glass. It is costly, but it gives a constant supply at 60 to 80 degrees centigrade. And then of course, the piping and why we should go in. Thank you friends, I think we had a brief about hot water supply in buildings, and hope to see you next time. Bye bye.